Hi, and welcome to 2.5 Multiview Sketching. So this is a little bit different from the pictorials that we've been doing because the pictorials try to represent what the object would look like if you're actually looking at the object. Multiview sketching is going to be useful when we're doing working drawings and dimensioning objects so that if we create something, we can send these working drawings to a manufacturer and they could build our products for us. So it's going to look a little different. So the glass box we've been talking about in terms of helping us build our pictorials, but there's another like glass box thing that you could think of with Multiview. The glass box to guide creation of multi-view drawings. So in this animation, they're showing you like you could fold up this clear plastic thing, and that's really the key part right there. Is it's projecting the outline of the object onto those faces. And those are your multi-views. There's multiple views, front, top, bottom, right, left, rear. Multiple views for that object. Multi-view drawing shows two or more two-dimensional views of a three-dimensional object. So the pictorials are three-dimensional views. Really, they're on two-dimensional papers, but they're showing a three-dimensional view. These are two-dimensional views. It provides the shape description of an object. When combined with dimensions, serves as the main form of communication between designers and manufacturers. This is an example of a multi-view sketch. Now, I kind of blocked out a lot of the views to ask you, what if you were just given this view, what do you think this thing might be? If you're only given one view, it might not be descriptive, especially because this is actually the top view. If I gave you the front view, you might know right away, what the heck is this thing? Do you have a better idea? What if you have the right side view? Now you probably can tell it's a chair. So there's our, looks like a isometric drawing. Oh no, it's perspective because these two lines are meeting. And then you could even draw the left side if you'd like. So this is a dining chair. So those are multiple views. And we're going to draw the front view, the right side, and the top. This is really showing, see how everything's lined up, lined up, lined up. And then the top of it. It has to be lined up. You can't just have the views off into space. This is the only one that's off into space. The one that's the pictorial can be over here. But when you're talking multi-views, like these two-dimensional orthographic straight-on views, they have to be lined up like that. So here's an example of when this would be useful is when you have dimensions. So you make your front, top, right side views, and then you can add dimensions to them. And you put this here for reference. So in case they can't figure out what it's supposed to look like, this is another clue as to, oh, okay, that's what the object actually looks like. All three-dimensional objects have width, height, and depth. Width is associated with an object's side-to-side dimension. Height is the top to bottom dimension, and depth is the front to back dimension. So this is an isometric view. Let's see what the front, top, and right side would look like. But more importantly, how would you set this up? So this is the top view. And see how it's in line? It has to be in line. And then again, in line there. They're showing that it's like rotating the object. So the front view you might expect, but like with the chair, if you were just shown this, would you be able to determine that it's actually showing this? So can you picture in your mind that the top view looks like that? Because like that, see how I drew like this? Boom, boom. And then the line in the middle over here. Okay, hopefully that kind of makes sense. I know some, and then the right side view is actually like this. And then, so that's the outline. And then this line in the middle is right here. So this portion is closer to you, and this is the thing that's angled backwards. So you have to kind of be able to picture that in your mind. So they're showing you the height, width, and depth here. And the reason we like to line it up is because if it's not lined up, you might not know that this height is equal to this height. And when you're dimensioning it, you only have to dimension one of the heights. So it's very important that the height is lined up and the width for the same reason is lined up, and even the depth. So if you get rid of this, that's how the depth works. All right, you have this weird 45-degree angle. So it's like this is equivalent to that. So an orthographic projection sounds fancy, but orthographic just means like 90 degrees. And a projection, if you've ever seen like a movie theater projection screen before, it's like you're putting something onto a screen. Well, we're going to be putting the object's outline onto not a screen, but they call it a plane in space. And again, orthographic means 90 degrees. So you're like looking right at that object from the plane. It's a technique used to create multi-view drawings, any projection of the features of an object onto an imaginary plane of projection. The projection of the features of the object is made by lines of sight that are perpendicular to the plane of the feature. The best way to understand orthographic projection is to imagine an object contained inside a glass box. This is what they started with that animation a few slides ago. There is a total of 6 glass walls surrounding the object. Each wall represents a projection plane onto which a two-dimensional object view will be created. Projection plane, also referred to as a plane of projection or a picture plane, is an imaginary surface that exists between the viewer and the object. The surface onto which a two-dimensional view of a three-dimensional object is projected and created. Start by focusing only on the front projected plane. A person standing in front of the object would see only the 5 corners identified in black. And this is what they were saying with the line of sight, and there's that 90 degrees for orthographic at 90-degree angle to the projection plane. So you're looking straight at that object. And at that point, you can't see the depth. You don't know what's going on behind here. All you can see is the outline. And that's what you're going to draw on this projected plane. Projection lines, and you wouldn't draw these lines, they're just using them as a reference to describe what's happening. Projection lines are used to project each corner that they were talking about outward until they reach the projection plane. A projection line is an imaginary line that is used to locate or project the corners, edges, and features of a three-dimensional object onto an imaginary two-dimensional surface. The visible edges of the object. So that's what I outlined before. This is a visible edge. This is what we can see. Remember, we can't see the depth from this flat on 90-degree view. We can't see what's going on back here. All we can see are the visible edges. And then they're identified on the projection plane by connecting the projected corners with object lines. So they're going to draw it like this. That's the purpose of those projection lines, is you're putting the points on the plane. And you get the outline like that. So that's your front view. The orthographic projection process is then repeated on the other projection planes. And now this is, I don't know why they chose a different object, but they chose this object, and they didn't even choose the correct front view because this long edge should be down here. So it's upward, it should be on its side right now if it's the right front view. But, you know, it is what it is. It's a nice drawing otherwise, but they didn't use or even use a ruler, but they're using hidden lines, so that's cool. Orthographic view selection. Recommendations for how to select the front view. The most natural position or use. shows the best shape and characteristic contours. It has the longest dimensions and the fewest hidden lines, and it's the most stable and natural position. So that last rule is what they broke with the previous view. Should have been flat down, most stable. So this is a slide that we saw before in a previous lecture. This is the best front view. Best shape description, no hidden edges, most natural position, longest dimension. If they were going to draw the front face of this, I think I did this even in the previous video. Let me see what color I should use. Maybe purple, why not? All right, so the front view would obviously look like this, and then over here, and then this would also be on the front view. But this line would be projected up, and when you're drawing it, it would be like that. So you're drawing, ignoring everything else. If you just had my purple lines, this is what the front view would look like. Okay. So the number of orthographic projections. One view is for things that have uniform thickness or shape. And if they're technically not showing you the depth, but they're telling you what the depth is here. And if it's a uniform thickness, all you need is one view to dimension the height and width, and then you just say, okay, everything is the same depth, 1/8 of an inch. Technically, for your Tetris shapes, that's the best way to do it because they're all uniform depth. But for your assignment, I'm going to have you practice drawing the top, the right side, as well as the front. All right, so you need to have 3 views, but this is just showing like best practice for when you're actually making working drawings. You want to be the most efficient as possible. 2 views would be identical. All dimensions properly and easily shown on one view. So whenever possible, try to do as few views as possible. All right, when do you have 2 views? So this is showing a front and a top view. Why would you need 2 views? If it's symmetrical, and if a third view would be identical to one of the others, so why put it if it's just identical to the other one? Or a second view is necessary for depth. So here we have a varying depth, and this is really the height, but you get the point. It's like not uniform, like a flat stock would be. Sketching a multi-view drawing. Given the overall dimensions of the object, a pencil, and a sheet of graph paper, sketching a multi-view drawing can be easily done using points, construction lines, and object lines. Step 1. Lay out the boxes within which the individual views will occur using points and construction lines. Do you remember how with all the other pictorials I had you start with a glass box and you drew the 3-dimensional box? This is the same thing, but instead of starting with a glass box, you're starting with a glass multi-view drawing. So you're making a line on the bottom and the top. That's going to give you your height. And then a line on the sides. That'll give you your width. And all of a sudden you have, this is the front face of like our quote unquote glass box. Then you can draw, they're drawing, this is the right side face of our glass box. Remember how like in isometric we had the front, top, and right side view? And then this is the top view. And you can even, you don't have to, but if you draw these lines all the way out, they intersect. And then that's like the depth thing that they showed before. So this is your front, top, and right side view of your glass box. Step 2 is to use construction lines between the views to indicate the geometry of the views. So I'll have another video of me doing the L shape, but basically what they did was they laid out what this front view is going to be, and then you take your construction line and put it all the way across. And you take this construction line, you put it all the way across here, and this will dictate what the rest of your views are going to look like. So this line needed to be there. And we know it's located there because it goes straight across. By putting your views in line with each other, it helps draw more concise pictures. So that's that line, that's that line. they're showing this edge here is right here, and it's also right here. Identify the visible edges within the with object lines. So now that you have your construction lines, you could draw the object lines just like before. You start with construction lines and then you draw the object lines. And then locate hidden lines. So this object line is here, and you can't see it from the front view, but you put the hidden line right there. And then same with this. This line is right here, and you can't see that from the front view, but they put a hidden line right there. Historical example, Leonard P. Carr designed a man-sized hunting blind shaped like a goose called Super Goose in 1991. How would you label the views presented in the drawing? Are Mr. Carr's views properly aligned based on the orientation presented here? And how would you rearrange the views? So that's some pretty good questions there. This looks like a top view to me. I might put it on the top over here. And then this looks like the left to me. Like this is on the left side. And if you move your view around here, like you'll say you're standing here and you're looking at the thing, well, that's on your left. And then you walk around to this side and you would see this. So they're saying, hey, he put his views in the wrong order. Pretty crazy. Okay, so this is important. Pause the video here. All right. It says each of the blocks at the right has the same overall dimensions and color. What else do they have in common? If you didn't pause the video yet, pause it and think about this. All right. What else do they have in common? I'll give you a clue. It has to do with one of their orthographic views. So which orthographic view, front, top, or right, would be the same? They all have identical top views. If you positioned yourself and you looked from the top, it would look like that on all of them, actually. So they all have identical top views, even though the shapes look different. So you're going to do 2.5 multi-view sketching practice. Make sure that you have them all 1 cube deep, including the square shape is 1 cube deep. I'm going to do a video right now of how to do the L shape in multi-view. The rules are going to be the same. I want you to choose the correct front view as shown in above here. All those up above are the correct front view. Use a ruler or straight edge. Some people aren't using rulers. You got to use a ruler or something straight. If you don't have a ruler, use the side of a notebook or anything that's a straight edge because I want straight lines, okay? No wavy lines. For multi-view, do not use tonal shading. You do not have to shade in your views. If you shade in your views, you're going to get points off. The shading was for the pictorials to give the representation of a three-dimensional object. Multi-view sketching are supposed to be two-dimensional because you're only looking at, if you're looking at the front, you're looking at the height and the width. And if you're looking at the right-hand side, you're looking at the height and the depth. And if you're looking at the top view, you're only supposed to be looking at the width and the depth. So you want them to be two-dimensional. See how I said two dimensions for each view? You don't want them to look three-dimensional, so why would you use tonal shading? Do not use tonal shading for these multi-views. I'm going to take points off. Even though I said it so many times, people are going to do tonal shading. Don't do tonal shading for the multi-views. You don't have to shade these in. It makes it look messy. You want nice, clean, efficient views. Do not include lines to make the parts look like multiple squares, especially with your multi-views, because if you start drawing lines here, it makes it look like there's an edge. And then what is your front view supposed to look like? Are you telling me that there's like different steps, like here would look like this? If you draw the unnecessary lines here, it makes it look like there's other stuff going on when there's really not. The top view should just be, um, one continuous thing. I know I'm repeating myself a lot here, but I guess it needs to happen because people still make the same mistakes every single year. And you know what? If you make a mistake, it's not like I'm saying anything against you. I'm just trying to be as clear as possible to try to avoid that. But if you make mistakes, just learn from them. Everybody makes mistakes. You don't think I make mistakes? I make plenty of mistakes. It's okay. That's about it. Thanks for watching and have a great day.